Okay, we have here the problem set number 4 for the torque. So this is the problem. Consider the situation below. The uniform 0.600 kilonewton beam is hinged at P. Find the tension in the tie rope and express your answer in three significant figures. So we have here the given, which is the weight of the beam equals to 0.60 kilonewton or 600 newton. And the word uniform here as significant later in the problem. And the weight of the object is 800 newtons suspended at length or the one whole length. Wherein the tension of that rope is at 40-degree angle supporting a 3L over 4. The required here is the tension. So for our equation, that is simply torque is equivalent to force perpendicular multiplied to the R. We all know that the R is the distance from the pivot. And that's simply we're making that equation to torque is equal to sine theta multiplied to the force applied multiplied to the R. Our solution here, so we all know that the sum of the torque, since this is not moving, according to Newton's first law, is 0. So sum of the torque is simply, what are the components? We have the weight of the beam, the weight here. So we can expect that we could draw one imaginary line here, which is 600 Newton. We have also the weight of the object. We have 800 Newton. And the perpendicular tension multiplied to R. So let's try to detect if it will become positive or negative. So we're having this as our pivot. So that weight of that beam, as we could expect, it will turn into clockwise. So therefore, the sign would become negative. The other component, which is the weight of the object, it will turn into clockwise. So therefore, that is simply negative. And the other component, it is counterclockwise. So therefore, that is positive. Okay, so the sum of all the torque is equivalent to negative 600 Newton times L over 2. Why L over 2? Simply because we have here the weight is uniformly distributed into the beam. So therefore, half of this is L over 2 minus 800 Newton. Since this object is connected at the end, and then we could have here the L plus the T. Now, let's try to recall what would be the tensional force. Okay? Now, let's try to draw here. So this would be the beam. And then we have here an angle which is 40 degree. So we have here as R tension. Okay, since we define torque as the force perpendicular, okay, so we have here tension perpendicular, and this one is the opposite of this 40 degrees. So this is the opposite side. Now, what function are we going to use? So simply, if we recall our SOHCAHTOA, we have SO, which is sine. And definitely sine 40 degree is simply opposite, which is our O, divided by hypotenuse. Okay, so we have here the opposite, which is this side, and this one is the hypotenuse. So therefore, we have your sine 40 degree, and the opposite side is the perpendicular tension. And the hypotenuse here is simply the tension of the rope. Deriving algebraically, we could have tension perpendicular is equivalent to T sine 40 degree. Therefore, this will be now our values for the tension perpendicular, which is equivalent to T times sine 40 degree multiplied to 3L over 4. Why 3L over 4 from the given itself? We have here the distance, 3L over 4. And so we have the sum of all the torque is 0 and then negative 300 Newton multiplied to L minus 800 Newton times L plus T sine 40 degree is 0.643 times 3L over 4. Now, we have to transfer this to the other side. Okay? So, this positive will now become negative equals negative 1,100 Newton times the L. We simply add this up. Okay? So, negative 300 Newton times L minus 800 Newton L, and that is negative 1,100 Newton times the L. Okay? So, this 1.643 times 3L over 4 or times 0.640 times 0.75, that would give us 0.482. So, T times 0.482 times L, and that is 1,100 Newton times L. We simply remove the negative to make our equation a lot simpler. We could cancel that negative on the both sides. So, we have here, divide both sides by 0.482 L. Could simply divide it and then cancel the 0.482 on this side, cancel the L, and then cancel the L on the other side. And therefore, the tensional force, we have 1,100 Newton divided by 0.482. That's simply 2,282.16 Newton. And remember, we have to express it into three significant figures, so we round it off to 2,280 Newton.